Alright, so we are doing our first lesson, our first learning objective of quarter 4. And the learning objective we are going to do first here is solving systems by graphing. Now, I'll explain what all that means in a second. Okay, before we get started, here's what I want you to do. I want you to look at these two equations. 2x plus 3y equals 7. And I want you to look at y equals 5x minus 3. Now I want you to carefully look at these two equations. And I want you to tell me what these two equations have in common. So stop the video for a second, look at these two equations, and take some time to study them and see if you can figure it out. Okay, so you probably came up with the obvious, and I don't want the obvious. I want the merely obvious. Like, for example, you probably told me that they both have an x and a y. Well, yeah, duh, of course they do. And they both have equal signs. Yeah, I can see that also. But maybe you need to look a little deeper than that. Maybe you need to think more about what do these two equations have in common. Stop the video again and look again. Do you notice anything? Well, maybe you didn't, but that's okay. Because what you will learn is that these two equations together form what is known as a system of equations. Now, one of the things that you will learn at some point throughout this unit is that we are going to look at 3 different ways of solving these equations. You're going to find the hard way, you're going to find the medium way, and you're going to find the easy way to solve a system of equations. Unfortunately, we have to start with the hard way. So let's take a look at these equations again. 2x plus 3y equals 7. And this time what I'm going to do is I'm going to look deeper at them, and I'm going to look at the lines, the graphs of these solutions, of these equations. So, for example, look at 2x plus 3y equals 7. And one of the things I want to do is I want to graph this equation. Now, by looking at it, it's not an easy one to graph, to be honest with you. I probably could have made that nicer for you on your first one, but why not? So I guess that, not being nice, I may have to find some points that'll work. Unfortunately, looking at this, the x and y intercept, they're not going to be nice. If I let x equal 0, y is going to be 7/3. If I let y equal 0, x is going to be 7/2. May not be as nice, but the 7/2 could work out a little better for me. So what was that? If y was equal to 0, then x was equal to 7/2, 0, which is really 3.5. So I can go 3.5, 0. And there's my x-intercept. And then my slope, which is really nice, is negative 2/3, which means I'm going to go down 2 and over 3. So there's another point, and what I want to do is I want to graph that. So I'm going to draw my line. Come on, there's my line. That is a terrible line. Let's redo that. Let's see. Wow, I was way off again. That's okay. You get the point. You get it? Point. Okay. Look at the other equation. Y equals 5x minus 3. This is an easier one. This one we know we're going to start at negative 3. We're going to go up 5, 1, 2, 3, 4, 5, and over 1. And there is this equation graphed. Now if you look carefully at my two lines that I've graphed here, you'll notice that they do have something in common. Matter of fact, what they have in common is this wonderful point right here. Because remember, a line indicates all the points that make the equation true. And this one, again, all the points that make this equation true. Well, this point here makes both equations true. So that is a solution to both lines, which is what these two lines have in common, which is the point 1, 2. And that's how we solve a system of equations by graphing. We actually graph the line. Okay, so now it's your turn. Let's see if you could do it. The trick here is you have to know how to graph lines, and since we just finished that, you should know how to do that. So let's have you do x minus 3y equals negative 4 and y equals 1/2 x plus 1. Would you find the solution to this system of equations? Pause the recording and try this on your own. Okay. If you did it correctly, you would have found that with the first line, I could easily find the x-intercept, and the x-intercept was negative 4. And then the slope came out to be 1/3, so I could go up 1 and over 3, and up 1 and over 3. And I could keep doing that until I get a little bit easier of a line. The more points, the better to draw. There we go. Now in the second one, it starts at plus 1. It'll go up 1 and over 2 and up 1 and over 2. So this line kind of goes like this. And we notice that the intersection point is that point, this point right here, which is in fact the point 2, 2. So, did you get 2, 2? Raise your hand if you got 2, 2. Is everyone watching you now? I think so. But that's okay, because you would have got it correct. So that is my solution. Okay, try this one. Try this one. Your equations are going to be y equals 3/2 x minus 2 and y equals 3/2 x plus 1. Pause the recording, try graphing this, and see what you come up with. Okay, if you did it, the first equation would start at negative 2, you would go up 3 and over 2, and I could do that again, up 3 and over 2, and up 3 and over 2, just because I want to have some balance there on my equation, and there's that line. Y equals 3/2 x plus 1 starts at plus 1, goes up 3 and over 2, goes up 3 and over 2. I could even go down 3 and back 2. And there is this line. So what is the solution to this one? Well, there is no solution, because the two lines are parallel. And because they're parallel, they will never intersect, which means they have nothing in common. There is no point they have in common. So it is no solution. Okay, let's check out this one. Y equals negative 3/4 x plus 5 and 3x plus 4y equals 20. Pause the recording and try this one on your own. Okay, if you did this one, you started with y equals negative 3/4 x plus 5, which means you started up at 5. You went down 3 and over 4. So your line kind of went like this. Oh my gosh, that was a terrible line, but you get the idea. If we do the next one, I found my y-intercept. I let x equal 0, and that told me that y was equal to 5. So I went up to 5, and then my slope for this one was, remember, negative a over b. So it's negative 3 over 4, which means I come here, which means, oh my, it's the exact same line. So how many points do they have in common? Well, that's easy. They have infinitely many solutions. Because every solution, every single point, every infinitesimal point is exactly the same. So there are infinitely many solutions. So let's review. With a system of equations, I could have one solution, and that's, by the way, the abbreviation for solution. That's where the lines intersect. I could have no solution. That's where the lines are parallel. Or I could have infinitely many solutions, and that's where the lines are identical to each other. They're the same line. So that concludes our first lesson on system of equations. You now will have a series of activities or work that you're going to do. You can check that out in Google Classroom. And once you're done with that, you will be able to check your answers and let me know how you're doing. If you need my assistance, call me over and I will help you out. So, good luck with your graphing of systems of equations.